So grade 7 girls, let us continue lesson number 3, absolute dating. Yesterday, I have told you some methods of radiometric dating. We studied about atoms. We studied about isotopes. Again, girls, isotopes are not easy for you because you did not study yet about chemistry. But still, you must have an idea. I told you, same element like hydrogen and hydrogen with same atomic number. Their atomic, this is the first element of the periodic table. But same atomic number, but different mass number. The number of neutrons, atomic number is protons. They have same protons but different neutrons. So they become isotopes. So similarly, we have radio isotopes that help you to determine the age of the difference between the parent isotope and then later they break into daughter isotope. When they know the difference between both of them, you can easily say the age of the substance. This is how they do the radiometric dating methods. Now they also told you, they gave you an example, uranium, and they gave you an example how they, see, they gave you here, they use potassium argon for igneous rocks. They use uranium for, again, igneous rocks, but 100 million years and a few billion years ago. Then, how is radiometric dating used to determine the age of Earth? I told you that there are no Earth rocks which can be directly studied that are as old as our planet, of course. You cannot study directly. Meteorites are small. Meteorites are small, rocky bodies that have fallen from space. Girls, I'll give you one example. In the Mesozoic era, we had dinosaurs. In the Mesozoic era, we had dinosaurs. Okay, but these dinosaurs, girls, they were all destroyed because they said that meteorites they had fallen on Earth. So that have fallen from space to Earth's surface, they are the same as the age of the solar system, including Earth. The absolute age of meteorites and other rocks in the solar system is about 4.6 billion years, girls. Imagine in the other planets, and the age of the meteorite is 4.6 billion years ago. Now, okay, now next. How can fossils help to determine the age of sedimentary rock? Okay, Judy, can you just explain me what did I say yesterday about igneous rocks? How are igneous rocks formed? If somebody is really listening to me, you will know how are igneous rocks formed. I told you yesterday about a volcano eruption. Explain me.
Yes. That inside the volcano is magma and it come out lava.
Yes, you have magma and you have lava. When this lava cools, it becomes igneous rock, which is very shiny. This is how igneous rocks are formed. Okay. Second rock, we are saying sedimentary. Sedimentary rock, whenever I say, you must remember they are soft rocks. Soft doesn't mean when you hold them, they just like sponge. Yeah, this seems to be hard. Usually they are white in color, girls. They are white in color, or when you crush them, they get powdered like a chalk. Especially when you go to beach and you find a rock, you just stamp on it and it become powdered. So this is kind of, they're not that hard like igneous. Igneous are too hard. How are they formed? They are formed by the sea, deep in the sea ocean, layers upon layers, when rocks are coming, rock particles with fossils. That's very important. With fossils, maybe dead ants or dead plants or dead animals, with the fossils, and they get compacted when some pressure comes on it, compacted, cemented. Like imagine you have a compact powder what you apply on your face. If it's a loose powder, the particles are moving here and there. If you blow a loose powder, it will blow into air. But when it's compacted and you blow it, it will not blow into air because it is pressed. You pressed it so hard that it became a layer. And similarly, sedimentary rock layers and the fossils within them cannot be dated directly. You cannot date them directly. But igneous rocks on the either side of a fossil layer can be dated radiometrically. Means what is the method for doing the igneous rock? It can be done with radiometrically. Yesterday, what did I say you? By using isotopes. By using radioisotopes. Now here. Radioisotopes. Once the older and the younger rock layers are dated, scientists can assign an absolute age. You'd see the younger rock, you see the older rock, and you see the range between them to know the absolute age to the sedimentary rock containing. How can fossils help to determine the age of the sedimentary rock? Continue. We have first that we take the younger rock age, we take the older rock age, oldest one, and we take the range of that. Second, they told us here about index fossils. These are fossils used to estimate the absolute age of the rock layers in which they are found. Simple, like I have a rock, I have some animal here, dead animal. The leftover, maybe the bones. I take those bones, okay, I take those bones here. Maybe it's a fish, I take that, or it's some dead plant or dead. And then I go to my lab and I see the age of that animal. By that, I can know that this animal existed in this year. Because seeing in the lab, they say how old the animal is. Once the absolute age of an index fossil is known, it can be used to determine the age of the rock layers containing the same fossil anywhere on Earth. Once you know this absolute age, age of rock layers, if they contain the same fossil anywhere, we can say that even that rock is so much old, so and so years old. Why only 3 girls came and the rest of them, they did not come for the class? Zishan, can you read this page? Judy, you read out, even Zishan is not.
To be an index fossil, the organism from which it formed must be live during a relatively short geologic time
Must have
span.
lived during a short geologic time span. Okay, next.
Index fossils must be relatively common and must be found over large areas.
Okay, it must be on the large area. Next, index fossils must also have features that make them different from other fossils. As I told you, even some of my organs, they are same like as of whale or as of some other animal. So it must have some related features that make them different from other fossils? Now, how are index fossils used? They act as markers for the time that the organisms were alive on Earth. They give you an indication. They give you an indication that that's what they say. The indication means here is markers. Index fossils can also be used to date rocks in separate areas. Not only we know the age of the fossil, we also know the age of the rock. By this, we end the lesson and we'll watch the video. Judy, can you just say the girls to join? Why didn't Miral and
Okay.
Zainab? Even Noor did not come. We have a class now, right?
Yes. Yes, I told them to join class.
Oh, let's leave it. Tomorrow we are gonna start with new lesson.
Okay.
Okay.
It will again start from the beginning.
Igneous rocks are the best type of rock sample.
Now see, they said they'll say you how igneous rocks are forming and how what is the use of this potassium 40 means. I told you the symbol is K40. That is an isotope, and how do we use it? It will explain you.
Igneous rocks form as molten material in Earth's crust cools and hardens. Various minerals are formed, each made up of different elements. Some of these elements are radioactive isotopes. When the igneous rock first forms, there are no daughter isotopes present. The parent isotopes must decay over time to create daughter isotopes. For every half-life, half of the amount of parent isotope is converted into the daughter isotope. Radiometric dating compares the amounts of each isotope to determine when the mineral formed. This is the absolute age of the mineral. The absolute age of the mineral is the absolute age of the rock because they formed during the same time. Radiometric dating does not work for all types of rocks. Sedimentary rocks are made up of particles from other rocks, rocks which may have formed long before the sedimentary rock existed. If a rock partially melts or is put under intense pressure, some of its minerals change and form new minerals. It becomes metamorphic rock. What if you want to know the absolute age of a metamorphic rock? Can you figure out why scientists might only measure radioactive isotopes in the changed new minerals of a metamorphic rock? The radioactive element potassium-40 is a parent isotope found in many rocks, such as granite. The daughter isotope is argon-40. The absolute age of a potassium-bearing mineral is found by the potassium-argon method of absolute dating. The amounts of parent, potassium-40, and daughter, argon-40, isotopes are determined in the mineral. The half-life of potassium-40 is 1.25 billion years. After 1.25 billion years, there should be equal amounts of each isotope. Other methods of absolute dating which work in a similar way, are shown in the The red dots represent parent isotopes in a rock sample. The parent isotopes have a half-life of 1,300 million years. What do you think will happen to the isotopes as you move forward into the future? Click to discover more. When a rock is first formed, there are no daughter isotopes. The rock contains only parent isotopes. After one half-life has passed, about half of the parent isotopes have decayed into daughter isotopes. How many parent isotopes do you think will be left after another half-life passes? 2 half-lives have now passed, and there are only 16 parent isotopes left, which is 1/4 the original number of parent isotopes. After 3 half-lives have passed, 1/8 of the parent materials remains. To determine the absolute age of an index fossil, scientists radiometrically date igneous rocks that are close.
Again, I'm saying you guys, igneous rocks can be done by radiometric methods. You cannot do radiometric using the radioisotopes for sedimentary rock. You have to go with the index method. That's a different method. But igneous rocks will go with radiometric data.
Closely associated with the fossil. This gives scientists an idea of the range of dates between which the index fossil formed. Because organisms that formed index Suppose when a rock formed, it contained 12 parent isotopes. The image shows how many parent isotopes remain compared to the number that were in the sample when the rock formed. If the half-life of the parent isotope is 1,300 million years, how old is the rock sample? Click your answer.
Guys, half-life is 1,300. So, of course, it will be double of
Right.
1,600.
1/4 of the parent isotopes remain.
That will be
So,
double, guys.
2 half-lives have
Half-life is
passed.
1,300. So, full life will be, how old is the rock? It is 2,600 million.
This moon rock was dated to be about 4.4 billion years old. 1/8 of the parent isotope remains. Is the half-life of the isotope used to date this rock 1.2 billion years? Click yes
Okay, they
or no.
say this rock was found on moon, okay? And they date it to be 4.4 billion years old. 1/8 of the parent isotope remains. Is the half-life of isotope used to date 1.2 billion year? 1/8 remain. That is 4.4 of 1/8 of 4.4 is, no, it cannot be 1.2, I think. If I divide 4.4 and 1.2, 12 times 2 is 24, 12 times 4 is 48, 12 times 3 something, 3 million years. No.
Well done. 1/8 of the parent isotope remains, so 3 half-lives have passed. That means the half-life of the isotope used is about 1.5 billion years. Relative dating and
I'm surely not including this in the test. It's a very dry topic, girls. You just, most importantly, here is like igneous rock are dated using radioisotopes, and sedimentary rocks are used by index method. All that, not that important lesson at all, girls. Okay.